I just received this package from China, and inside are two boxes with Goovis brand name on them. The brand name alone tells you this is definitely a product from China, and the brand was invented by someone with poor command of English. They probably wanted to combine Go and visual, making it visual on the go, but ended up with something sounding goofy or goofies. Anyway, like many others, this brand started as a crowdfunding campaign on both Kickstarter and Indiegogo, and this company produces 3D head-mounted displays which you can carry with you, hence the name, Visual on the Go. They've been around for a couple years and have several products in their lineup, and this is their latest product, which is a light version. But before we dive in a deeper review, I would like to point out that the box says Personal 3D Viewer. This is important since some early marketing materials from Goovis stated that this is a VR headset, which it is not. This is a 3D capable, stereoscopic head-mounted display, but this is not a virtual reality headset. A virtual reality headset is mostly two things: immersion and head tracking. Immersion is achieved through a wide field of view. That means that when you put on the virtual reality headset, the lenses make the picture all around your eyes. So wherever you look, you still see the picture. And when you move your head, the head tracking changes what you see accordingly. This is called degrees of freedom, and VR headsets come in two main varieties: 3 degrees of freedom and 6 degrees of freedom. 3 degrees of freedom is mostly for viewing those 360 videos, and the most popular and well-known devices are Oculus Go, JRVR, Google Cardboard, and all those headsets where you can insert your phone and use the phone screen and gyroscopic and other sensors for head tracking. So basically, in a 3 degrees of freedom headset, the viewer is in a fixed position. However, you can rotate your head and see the environment around you. The 6 degrees of freedom headset, or full virtual reality, adds 3 more degrees of freedom, and in devices like Oculus Quest and other headsets, you can actually freely move in the virtual environment, see the objects from all perspectives, and interact with them. Even newer headsets, for example Oculus Quest 3, also add the eye tracking capabilities, and they can track not only where your head moves, but also where your eyes move and what they see. On the contrary, a stereoscopic 3D head-mounted display has a more narrow field of view, that means less immersion, and has 0 degrees of freedom. That means it doesn't track your head movements. Basically, using a head-mounted device like this is like looking at a big 3D capable display from some distance away. So this device is mostly for watching 3D or 2D video content, as opposed to experiencing virtual reality. This is not a good or a bad thing. VR headsets and HMDs are just different devices for different purposes, although they look somewhat the same. This Goovis Lite is very similar to a Sony HMZ T1, a 3D HMD, which I owned about 10 years ago and even released several videos about it in my early YouTube days. I quite liked the Sony, however it had some major flaws, and finally I decided to sell it. However, I still liked using it and been looking around for something like it, and that's how Goovis came along. So I will be mostly comparing this to Sony HMZ T1, and actually I'm quite interested if this Chinese device doesn't have the same problems that the Japanese Sony did. Anyway, back to the review. Here are two boxes. The smaller one is a wireless device, which I will talk about later, and the big one is the main show. Inside the big box is a carrying case, and inside the case is a cable, a few straps, and the 3D display itself. The first thing to notice is how light it is. The device weighs about 200 grams. The materials used are mostly plastic, however there is a metal hinge that connects the forehead rest to the goggles. The device is mounted to your head with a few very basic elastic straps with some Velcro, however they seem to work just fine. The forehead piece is placed on your forehead. The metal hinge allows the goggles themselves to be flipped up and down, much like a night vision device on a helmet. That means that all of the pressure goes to your forehead and not your eyes or nose, making this an extremely comfortable headset to wear, which you can use for an entire day without much fatigue. On the rear of the goggles, there is a vent which acts as an intake for the onboard fan. Yes, this device has a fan. And also two adjustment knobs, which independently adjust the left and the right lens. The knobs can move left and right once again independently, so you can adjust the distance between your eyes. It's very important that this can be done independently, since in Sony HMZ T1 these knobs were linked together by a sprocket, and if you wanted independent adjustments, you had to disassemble the Sony and remove a sprocket. Here you don't have to do that, the adjustments are independent. And also, here is a very cool feature that allows you to correct the lenses if you're farsighted or nearsighted. The knobs rotate with a definitive step, and you can adjust your vision from +2 to -7. That means that if you have some eyesight problems and you have to wear prescription glasses, you don't have to wear your glasses while using this device. You can easily adjust this device according to your prescription. This is a unique feature since none of the other headsets, at least that I'm aware of, have it. You can order prescription lenses for Oculus Quests and other headsets, but you have to order them separately. And it also will be very difficult to use the device if several people with different vision problems want to use it, since you will have to order different pairs of prescription lenses. Here, you don't have to order anything, you can adjust your vision right on the headset. This is a very cool feature, by the way. However, it's worth noticing that if you have astigmatism, you cannot adjust this device to it. The lenses are quite decent as well, and they seem to have some coating. The soft pad around them is made from some resin-like non-porous material and should be quite easy to clean. The problem is this pad leaves a gap between your face and the device, and that means it allows some light from the outside come into the goggles while you're using them. For example, if there is a window to the left or to the right of you and it's daytime, the window can be reflected on the lenses. So it's really advisable to use the goggles in a darkened room. You may have noticed that this headset doesn't have earphones. Instead, they have an audio output connector, which is a standard 3.5mm jack. So you can use any headphones or earphones you like. Personally, I prefer this approach since the Sony HMZ T1 had horrible inbuilt headphones that you could not remove and use your own ones. So I definitely prefer not having headphones on a 3D headset. However, please note this is audio out only. So it can only output audio and not receive it. So this is an audio out and not audio in. You cannot plug in microphone or headset to it. The jack faces directly backwards. However, even large headphone connectors do not seem to be in the way of even the largest cans. However, to avoid the issue of the connector hitting the headphones, you should use earbuds, headphones with an angled connector or an angled connector adapter, or just go wireless. The device also has 3 buttons. One is used to control the brightness, and the other switches from 2D mode to 3D side-by-side mode. There is also an optical sensor to turn off the displays when you are not using the headset, and a permanently wired HDMI cable. Actually, I have mixed feelings about this built-in cable. Since it's not detachable, That means that you will have a really bad time trying to replace it, since this will involve taking apart the headset and soldering very thin wires. Or maybe they use some kind of an internal connector, which will certainly make replacement easier. On the other hand, those headsets that do have a connector usually tend to develop problems with that connector. Since it's very tiny and has to endure a lot of stress when you constantly move around pulling the cable, oftentimes the connector breaks, and in case of Oculus, which also has an inbuilt battery to power it, very often the connector just melts while charging the device. This Goovis headset has no inbuilt battery, so that shouldn't be an issue. And the greatest thing about this Goovis headset is that it is a complete device. That's it. It has an HDMI cable which you can plug in almost like a desktop monitor and use it. And it's very light and portable. This is a massive improvement over Sony HMZ series, which had a special set-top box which acted as a controller for the headset itself, and you could not use the Sony HMZ headset without that box. And that box is mains powered. There is no way you can use it on the go. Here, there is no additional boxes, you just have this headset and that's it. It just works. However, there is one minor issue. The device still needs power, and HDMI alone cannot provide enough current to power this device. That's why it comes with a special splitter cable which has a female connector for the headset HDMI out, a male HDMI connector which you plug into your source, and a USB connector which you plug to any USB power source. That may be the source device itself, if it also has an USB out, most devices nowadays do, or it may be an USB power brick, or a power bank. Anyway, this device needs power, and you cannot power it from HDMI alone. That makes this splitter cable an essential part of the package. And the funny thing is, in some marketing material, Goovis presented this adapter as a free gift. It's not a gift. This is an essential part of the package, and in most cases, you cannot use the device without it. The only exception are the additional devices produced by Goovis. They make a portable player and a Miracast/power bank combo which can power this device through HDMI alone, and you don't need the splitter cable. So let's have a look at such a device. This is a wireless Miracast module and a power bank combo. Actually, these are two separate devices which are held together by magnets and connect to each other with spring-loaded pin connectors. The power bank base is basically a 6 amps battery which can be charged with the included USB Type-C cable. Other than that, it's your standard USB power bank with several LEDs indicating the charge status and with a button to switch it on and off. That's it. The Miracast part has a spring-loaded PEC connector that attaches to the power bank, but you can also use it without the power bank by supplying power to it through a USB-C port. It also has a reset button and two output connectors. One is HDMI and the other one is Type-C. Type-C is used for one of the Goovis models, which is called Young. And the HDMI port is a special one. Not only it carries the HDMI signal, but it also carries power. That means that with this Goovis device, you don't need the splitter cable to use the headset. I have to underline that this is a proprietary way of using HDMI, and probably Goovis devices are the only ones capable of supplying enough power for the headset to work. This is a non-standard proprietary way to carry power. With all other devices, you will have to use the splitter cable, which is standard and should work with all HDMI-enabled devices. However, you will also need a USB port to power the goggles. The power bank base is a somewhat confusing name. This is not a power bank since you cannot charge anything like your phone from it. This is a proprietary device with a proprietary connector to provide power to the Miracast module and the headset, and it also has a nice button to turn them off. That's the sole purpose for this device to exist. You don't actually need it, as the Miracast model can be also powered from a standard Type-C connector. You can use any other power bank or wall socket to power it. If the power bank doesn't have a power button, you may just need to physically disconnect Miracast when you don't need it. When using a third-party power bank or a power brick, the Miracast module will still be able to power the headset without the need to use the splitter cable. Just make sure your power bank or wall adapter can output at least 10 watts. That is 2 amps at 5 volts of USB power. That's all that it takes to power up both the Miracast module and the Goovis Lite headset. However, I have to admit that the Goovis branded power bank base is quite convenient. It also lasts a few hours on a single charge, and even though it gets quite hot, about 40 degrees Celsius, there is nothing to worry about. So this is a convenient little device, but it's not a power bank, it's a USB charged battery. Anyway, this is a standard Miracast compatible device, and the setup is pretty much similar to any other Miracast devices out there. You can use it in two modes, either by connecting directly to it via Wi-Fi, for example from your phone or laptop or computer, and obviously you will not be able to use the device's Wi-Fi connectivity for other purposes, for example for going online. So a better way is to connect the Miracast to your existing Wi-Fi network, that is your router. This is actually quite simple to do. First of all, you need to connect the goggles to the Miracast module and look inside the glasses. It will display instructions with several QR codes and offering you to download some apps to supposedly easy up the setup process. I tried downloading one of them for Android, and this app is junk. You don't need it. You can connect Miracast via standard options in Windows, Android, iOS, and even Linux without resorting to shady apps which are filled with ads of other shady apps to do Miracast. So I installed this app just to show it to you and then immediately removed it since you don't need it. Basically, what you have to do is first connect to the Miracast from your device directly. The password to the Wi-Fi network is 128. After that, you have to open a browser and go directly to the Miracast device IP. You can find the IP address in the Wi-Fi status of the network, or just looking at the Miracast where this IP address is printed. After you punch it in the address bar of your browser, you will be presented with a list of Wi-Fi networks that the Miracast module has detected. You have to select your home network, enter the password to the Wi-Fi from your router. The Miracast device supports both 2.4 and 5 GHz network. I strongly advise you to use the 5 GHz one. Anyway, enter the password to your router's Wi-Fi, wait for the Miracast to connect. You can actually see the status of connection in the upper right corner of the screen inside the goggles. So basically this is a two-step process. First you connect from your Wi-Fi enabled device directly to the Miracast module, enter the password to your home Wi-Fi network, wait for it to connect to the router, and that's it. The setup is complete. After the setup is complete and the Miracast module is successfully connected to your router, you may now connect your phone or other device back to the router's Wi-Fi, and now it will be able to communicate to the Miracast, which is now connected to the same router, so all devices are on the same network. You may also want to disable auto connection to the saved direct Miracast network, so your phone will not try to connect directly to it. Since after the initial setup is complete, you don't need to do that anymore until you reset the Miracast module with the onboard button. After the Miracast module has successfully connected to your home Wi-Fi network, all devices connected to your router, both wirelessly and through a LAN cable, would be able to cast to the Miracast. For example, in Windows, you have to hold the Win key and press P or K on your keyboard and select the Miracast wireless display from there. However, on my first run, Windows was unable to connect to the device. To resolve the issue, I had to power down the power bank and switch it back on. After the Miracast device has rebooted, I was able to successfully cast from Windows to the goggles wirelessly. To do this on your phone or tablet, for example in Android, you have to select the Cast option from the drawer menu, and assuming your phone is on the same Wi-Fi network, you can just choose the Miracast device to cast to it. Once again, I wasn't able to do this on my first run. The phone kept on trying to connect to the display but couldn't do that, and to resolve the issue, I had to reboot the phone. After I did that, the cast functionality immediately worked, and I was able to successfully cast media, for example movies, using, for instance, VLC player. Of course, you don't have to go wireless, and you don't have to buy additional devices like this Goovis Miracast and powerbank combo. You can connect the goggles directly to any device which has an HDMI output. That can be your computer, your laptop, Steam Deck, your TV box, DVD player, Blu-ray player, game console like Xbox or PlayStation, or any other device that has an HDMI out. You will obviously need the splitter cable and use the HDMI plug to connect to the output, say your video card, and the USB plug to any USB socket. That may be any USB socket on the computer, or a power bank, or a USB wall wart. Any USB power source will do. And those devices that do not have an HDMI out, like most phones and for instance Nintendo Switch, without the base, can still be used with third-party OTG USB adapters that provide an HDMI out. After that, Goovis will be detected as a standard HDMI monitor, and you can use it as a standard display. And here comes the muddy part. Let's discuss the specs. I'm making this video review in December 2022, and by this time, Goovis has released 4 headsets. The first one, G2, in 2018, followed by Pro in 2019, then Young in 2020, and finally the star of this show, Goovis Lite, in 2021. They have plans to release the 5th generation next year. However, currently there are 4 models, they are all in production, and the first 3 of the 4 models are using the same displays. Most VR headsets, for example Oculus, and all those contraptions where you have to insert your phone to act as a screen, use a single panel, and both lenses are focused on left and right part of the same display. Unlike VR headsets, HMDs, that's head-mounted displays, usually have 2 separate screens for each eye. So the left lens is focused on its own screen, and the right lens is focused on another screen. These are 2 separate, identical screens. All Goovis models seem to be using Sony AMOLED displays. However, the first 3 models use a 0.71-inch AMOLED panels, while the Goovis Lite uses 0.49-inch AMOLED display. All of them manufactured by Sony. In a head-mounted device, a smaller screen is not a bad thing. First of all, you can obviously make the device smaller and have the panels closer to your eyes, and moreover, since all the screens have the same resolution, they are all Full HD screens 1920 by 1080, and that means having the same amount of pixels on a smaller surface results in a more densely packed pixels. And that is actually good. More densely packed pixels combined with a smaller field of view and Goovis Lite has a smaller field of view, eliminates the so-called screen door effect. The name comes from mosquito mesh that you normally find on a door or on a window. And when you look outside through this mesh, you can still barely see the blurred lines that form the grid that makes the mesh. A similar effect may happen with head-mounted displays and especially with VR headsets. Since the pixels are not too close and the field of view is larger, you can actually see the blank spaces between the pixels that form a certain kind of grid somewhat resembling the mosquito mesh. That's why it's called screen door effect. Since the Goovis Lite panels are smaller, they have a more densely packed pixels, and Goovis Lite doesn't seem to show this effect. So there is no screen door effect on Goovis Lite, and that's a good thing. So Goovis Lite not only has a relatively narrow field of view and densely packed pixels, but also these OLED screens seem to be newer, and since they are OLED, they do a much better job with shadows and dark parts of the image. The larger screens of the previous models were plagued with black level issues in certain movies with abundance of dark scenes, and some color tone temperature issues as well. The new screens don't seem to have this issue, at least I don't feel like I need to adjust anything. Anyway, even if you wanted, Goovis Lite doesn't have any built-in way to adjust color temperature. You will have to do that at the source, that is, in your computer video card control panel or in a software player. And actually the color tone, and especially the black levels, is the reason why you can only use OLED screens in head-mounted displays. OLED displays or AMOLED displays can provide deep blacks since they don't have a backlight. The drawback of OLED is the unavoidable degradation of OLEDs over time. After a certain period of time, OLED screens may experience a burn-in, especially if you use them for computer purposes, where certain interface elements, like the taskbar, are in the same place for the majority of the time. And also over time, the color becomes less vibrant. And that happens differently for different colors, so the degradation of color reproduction is not even. That's the drawback of all OLED and AMOLED and other types of OLED displays at the moment. That's why this device has a sensor to turn off the displays when you are not looking into them, so they work less and last longer. That's why this device has a fan, since it's a very good idea to cool down the OLED displays, as well as other components inside. Even though the fan has no speed control, it always goes full bore, it's pretty silent and you cannot hear it in your earphones. This is probably achieved through some kind of suspended flexible mount. However, if you move your head somewhat quickly, the fan makes weird noises as if the blades are touching something. That's not a big issue, it's just a minor annoyance. There is also an interesting parameter here, which is named virtual screen size. The idea between HMDs has always been giving the user an illusion of being in a large room looking at a large screen, for example like in a movie theater. For the first three models, Goovis claims equivalent of 800-inch giant screen at which you look from 20 meters. For the Goovis Lite, they claim an equivalent of 150-inch screen, which is 5 meters in front of you. This is simply not true. All HMDs I tried to use have the same feeling, which I call Alice in Wonderland. So the experience is not being in a large room like a theater room. You don't actually get the feeling that the screen is big. Instead, you get the feeling that you're Alice in Wonderland who has shrunk down, and you're looking at a normal-sized screen. The difference is you are small, not the screen is big. That's why I call it Alice in Wonderland. So in my living room, I have a 55-inch TV, which is about 2 meters from the couch. And using Goovis is very similar to watching my TV from the couch. So I would say that the actual virtual screen size is something like looking at a 60-inch display, which is about 1.5 meters in front of you. And that's it. And also remember that since Goovis doesn't track your head, this display is glued and bolted to your head. Never mind how you tilt or rotate your head, the screen is always in front of you. There is no head tracking. Anyway, the Full HD 1080 resolution of these screens is a big improvement over Sony HMZ, which was only capable of 720 HD resolution. However, I would like to address the real elephant in the room, which is the video format section of this spec sheet. As you can see, all of the Goovis headsets are able to display at least 2D picture. And that's the only format that Goovis Young supports. Goovis Young doesn't offer any stereoscopic 3D functionality, and basically this model is just your regular computer monitor strapped to your head. It won't be able to show 3D videos. All the other headsets, including Goovis Lite, can accept at least one 3D format. A brief explanation about delivering 3D content is probably required here. The reason humans and some other species are able to see the depth in the world and the volume of objects is because humans have two eyes facing in the same direction, somewhat apart from each other. This gives two visuals of the same object from a slightly different angle. The brain combines those images, enabling you to see the depth of the picture. If you look at something and close one of your eyes, you immediately lose the sense of depth. So to create 3D visuals, we need to somehow recreate this process and provide a separate image of the same objects from a slightly different angle to each of the eyes. When shooting real-life pictures, this is usually done with a special rig which consists of two cameras facing in the same direction, somewhat apart from each other, and shooting two streams of video of the same object at the same time. In generated content like 3D games or CGI movies, the virtual scene is also presented from two separate point of views slightly apart from each other to create two pictures of the same object from a slightly different angle. This is called geometric 3D. That means that each object has the full volume characteristics and looks very real. There is also an inferior technique which is called Z-buffer 3D. That is basically placing flat 2D objects at different depths. So the objects are still flat, but you can see how far apart they are. After you have the content, you need to somehow supply each eye with a separate image from a slightly different angle. This is achieved through various means. Some devices like Nintendo 3DS has special screens that can reproduce 3D images right on the screen. However, in most cases, you would require some kind of glasses to see the image. There are two types of glasses, shutter glasses and polarized glasses. Most consumer TVs use the shutter glass system. Shutter glasses are what they are. They are synced to the screen, and when you put on those glasses, they continuously block one eye from receiving picture from the screen. So basically, first they shut the left eye, then they open the left eye but shut the right eye, then they open the right eye but shut the left eye, and so on. Since they are synced to the TV, at a certain point in time, the screen shows only picture for one eye at a time. But since this happens very fast, you don't really notice it, and due to the persistence of vision, each eye is able to receive its own picture from its own viewpoint with its own angle, and you get the perception of depth. The polarized glasses are not synced to anything. They are very cheap to produce and mass manufacture, and they are mostly used with projectors, like in cinemas, but some consumer devices that use polarized glasses also exist. In polarized 3D, both images are projected on the screen at the same time. However, image for one eye is polarized against the image for the other eye, and the glasses in the goggles are polarized in the same way, and that's why each eye sees only the picture that is intended for this very eye. However, most 3D headsets produce the image for both eyes simultaneously. As I said, in most VR headsets, this is achieved by focusing the lenses on left and right parts of the same screen. So for example, the left part of the screen has the image for the left eye and the right part of the screen has the image for the right eye. Or as is the case with Goovis and Sony HMZ, each eye has its own separate screen. And you also need a way to send the image to the screen. HDMI 1.4 introduced something which is called frame stacking. Among all the Goovis product line, the only headset that actually supports stacking is the Goovis Pro. So basically, frame stacking is two images stacked together. For Full HD video, a single frame is 1080p. That means 920 by 1080. For 3D Full HD, the horizontal resolution is the same, 1920, however, the vertical resolution is doubled, and there is also a black line between the images. So basically, the top image is intended for one eye, and the lower image is intended for the other eye. That's how 3D content is actually transferred to the display. Obviously, this at least doubles the bandwidth required to send such image, and it also doubles the space required to store such files. That's why mostly this option is used in 3D Blu-ray discs. However, there is a different approach. You can take your normal standard 1080 frame, split it in half, take the two images required to form a 3D picture and squeeze them inside the single frame. You are basically changing nothing. The file size remains the same, the bandwidth remains the same, all the standards and connections and formats remain the same, and if you play such video on a normal, non-3D enabled display, it will play just fine. The only problem, you will be seeing both images together on the screen. There are two ways to put both images inside one frame. The first one is called over-under, and the second one is called side-by-side. Obviously, in the over-under configuration, one image is at the top and the other is at the bottom, and in side-by-side, one image occupies the left part of the screen and the right image occupies the right part of the screen. Obviously, as the original images were full frame 1080p, you will have to deform them to squeeze both images in a single frame for this to be still compatible with normal non-3D equipment. To make the stereoscopic image, the 3D display, the Goovis Lite in this case, takes one part of the image to be shown for one eye and the other part of the frame to be shown for the right eye. So it takes half of the frame, which is squeezed, enlarges it to fit the entire screen, and sends it to one of the displays in the goggles. Then it takes the other part of the image, restores the aspect ratio, and shows it to the second eyepiece. So you can view the content in stereoscopic 3D. The only problem with that is since we had to fit two frames in a single frame by squeezing them, that means that in side-by-side mode, you retain the vertical resolution, however, you lose half of the horizontal resolution. And this is the only 3D mode which is available on Goovis Lite. So you have to send a side-by-side image, then press the button on the headset to switch it to side-by-side mode to be able to see 3D stereoscopic content with half the horizontal resolution, which is kinda stupid, since the goggles have very capable Full HD screens which you can perfectly use to enjoy 2D content in Full HD, however, you can only see half of the resolution in 3D mode. Finding video content in side-by-side mode is not a big problem, since most streaming services that still stream 3D movies use side-by-side to send the bandwidth. Also, lots of 3D rips of popular movies that can be downloaded online are also in SBS, so there is no issue with actually obtaining 3D content in side-by-side mode, a bigger problem may be games that have to output SBS if they want to enable stereoscopic viewing. However, not many titles are still released in stereoscopic 3D, so that doesn't matter as much. But still, this is my main issue with this headset. I would really prefer if it could show 3D content in full HD resolution rather than side-by-side mode. Talking about resolutions, when connecting the headset directly to my PC and getting power from an USB, I could get the native resolution of 920 by 1080 with 60 Hz refresh rate. When using it wirelessly in Miracast mode, I could get 60 Hz at 1024 and at Full HD it was only 30 Hz. I believe this has something to do with the Miracast standard. Anyway, most movies and other types of video content you get is normally either 24 FPS or 30 FPS, so this is quite okay for watching movies wirelessly. The wireless mode surely adds a little bit of lag, maybe a couple milliseconds, but that's not really an issue if you are using it to watch movies and not play games. I had also no problem getting sound. The headset can receive audio from both HDMI and Miracast. However, I advise you to keep it in stereo mode since I don't think that it can downmix multi-channel audio like 5.1 or 7.1 to stereo. So keep it stereo at the source. Also, the inbuilt amplifier that powers the headphone jack is somewhat inferior to the one that is installed in my desktop monitor, and which I use to output audio from my computer via HDMI. The sound is okay, but I have a feeling that when connecting the same headphones to my monitor, I get a better quality of sound than connecting them to this headset. But that's how I feel it. Maybe there's no problem. That just seems to me so. With all that said, I really enjoy this device. When connected to the computer, you can use it in 2D mode with full HD resolution, and the image is very sharp and clear even at the very edges of the screen. This was a huge problem with Sony HMZ since I couldn't get the entire image clear. Here, there is no distortion, even the smallest text is perfectly visible and readable, and since it's Full HD, you don't need to use scaling to actually be able to see the fonts. As for 3D content, I personally think that head-mounted displays are the best way to enjoy 3D movies. Especially if they don't have the head tracking, so you can relax and put your head in any position or even lie down with your goggles on to watch a movie. The 3D effect is very strong, especially the pop-ups. They look very nice in this headset. However, you have to keep in mind that this is a personal 3D viewer. That means that only one person can use it at a time. You can't really enjoy 3D movie with your partner, friends or family together with this device, since it's personal. And of course you can watch normal content, 2D movies, in full HD resolution as well. Other use cases that I can think of is using it with anything that has an HDMI output. The problem is, when you take a VR headset, they normally do not accept HDMI input. You simply can't connect them, for example, to your Blu-ray player to watch a movie since they don't have the connection. There are some junky solutions, but they are tedious and not very straightforward. Here, Goovis has a standard HDMI connection that works with all HDMI devices, including Steam Deck. Since this is a very light headset, it weighs only 200 grams, you can take it around with you, connect it to your Steam Deck, and enjoy playing games on the big screen while on the go. And I cannot stress using these goggles with Steam Deck enough, since Steam Deck has a horrendous screen. Not only it is very tiny diagonally, it is also not Full HD, it's only HD 720. With this headset, you can play on your Steam Deck as if it is connected to a 60-inch OLED TV in your living room. You can also connect it to your computer or your laptop to have a big screen on the go, and since this is a personal device, you can disable your main display, for example laptop screen, and use these goggles as your monitor when you need some privacy. No one will be able to see what you are looking at on your screen. The only possible issue here is the cable length. It is long enough for using everything that sits on your desk, for example a laptop. However, if you use it with a desktop computer and the case is stuffed somewhere under your table, the cable may be not long enough for comfortable use. However, you may use an HDMI and USB extender to make it longer. These goggles can also be used as a monitoring device while shooting videos outside, since very often it's hard to see the viewfinder on the camera, especially in broad daylight with lots of sunlight. Using Goovis Lite as a viewfinder even in the most sunniest of the days. You can also connect them to a drone controller if it has an HDMI output to be able to fly your quadrocopter with point of view perspective. I wonder if any of the quadrocopters have dual cameras to send back a stereoscopic image, since it will be very cool to fly drones with stereoscopic vision to see the depth. Anyway, I'm quite happy with this device. I will definitely be using it, at least for watching 3D content. It is definitely much better than the Sony HMZ T1, which I had 10 years ago. My only problem with this device is that it does not support full real 3D transmission. You have to stick with SBS format, but that's kinda fine. I really hope that Goovis will address this issue in their upcoming new version of this headset if it ever will get released. Until then, if you are interested in buying any of the Goovis products that exists now, follow the link in the description below. I am the god of YouTube. Like, subscribe, thanks, jingle bells.